Good afternoon. My name is Manoj Kumar, Assistant Professor from Department of Computer Science and Engineering, Ajay Kumar Garg, Engineering College, Ghaziabad. Today in this lecture, we will learn about the stack and array implementation of stack. So this is the content that I will cover in this lecture. First, we will see the introduction of the stack. After that, application of stack and the push and pop operation on a stack. After that, we will see the stack implementation using array, a C program to implement the stack. And in the last, we will see the infix to postfix conversion. So stack is a linear data structure that follow last in first out principle. It means stack is just used to store the data element. It is a linear data structure and it is a last in first out data structure. It means the element which will be inserted in the last, that will be removed first. Okay. Stack has one end, whereas Q has two end, front and rear. Q is another data structure which has two end, front and rear. At front, we will remove the element, and at rear, we will insert the element. But in case of stack, there is only one end to remove the element or to insert the element. It means, and that particular end is known as the top of the stack. So in case of stack, the element can be inserted at the top and element can be removed from the top. Okay. So stack can be defined as a container in which insertion and deletion can be done from one end, and that end is known as the top of the stack. So this is the basic definition or basic introduction of the stack. Next, let us see the application of stack. What are the different types of application where we can use the stack in programming. So the first and most important application of the stack is the string reversal. Suppose we have to find the reverse of a given string. In that case, we can use the stack. That we can implement a program using stack to find the reverse of a particular string. Because suppose we have a string CSCIT. Now we have to find the reverse of this string. So reverse of this string will be TIES. C. It means when we insert this string in the stack, then first C will be inserted, after that S will be inserted, then E, and then I, then T. Again, when we remove this string characters from the stack, so first T will be removed, then I, then E, then S, then C. So in this case, when we delete the characters of the string, so we will obtain the reverse of the string. So stack is used to find the reverse of the string. Second application of the stack is recursion. As we know that recursion is a function that call itself again and again. There are different types of problems in mathematics that can be solved using the recursion. Like suppose we have to find the factorial of a given number, we have to print the Fibonacci series up to the nth term, or we have to find the sum up to nth numbers, or we have to implement the binary search, we have to implement the tower of Hanoi problem. So all these problems can be implemented using the recursion, and wherever we have to use the recursion, or we are going to implement the recursive and iterative approach, in that case we can use the stack. Okay. So all these problems can be solved by you implementing the stack. Third application of stack is the DFS. DFS is basically known as the depth first search algorithm. This algorithm is basically used to traverse a graph. Graph is a non-linear data structure. In that case, this particular algorithm is used, and this algorithm use the concept of stack to implement. Next, backtracking. Backtracking is another important approach that is basically used in case of dynamic programming. So in case of backtracking, stack can also be used. Next one is the expression conversion. Any expression basically contains two things. First one is the operator and second one is the operands. So in programming or in mathematics, any application expression may be represented in two forms. Generally we use the infix. Infix is the most widely used form. Infix form, prefix form and postfix forms. In case of infix form, the operator is placed between the operands, whereas in case of prefix form, the operator is placed before the operands, and in case of postfix form, the operator is placed after the operand. So whenever we have to convert an expression from one form to other form, like from infix to prefix, from infix to postfix, or from prefix to postfix, or from prefix to infix, or either postfix to prefix or postfix to infix. In all cases, we can use the stack. All the expression conversion can be implemented using the stack. Next application of the stack is memory management. Stack is also used to manage the memory, or we can utilize the memory efficiently using the stack. How? We in our program we use several local variable, declare and use local variable inside the function. So memory allocated to the local variable means whose scope and lifetime is limited within the block in which it is declared. So that local variable is get the memory from the stack. So stack also play an important role in memory management. So these are some real world application where we can implement or where we can use the stack: string reversal, recursion, DFS, backtracking problem, expression conversion, and memory management. Now let us see the push operation on stack. There are two important operations on the stack: push operation and pop operation. Push operation is basically used to insert the element in the stack. So whenever we have to insert the element in the stack, then a stack can be implemented using array, or it can be also implemented using linked list. But when we have to implement the stack using array, in that case we have to define a maximum size of the stack. Okay, so before inserting any element, at first we check whether there is any space in the stack or not. Okay, so for that purpose we check stack. If stack is full, then we will simply print the message element cannot be inserted. But if there is an space inside the stack, then what we will do, at first we initialize the top as -1, because top as -1 basically it represents stack is empty. So when we have to insert any element, before inserting the element, at first we have to increase the value of top by 1, and the new element will be inserted at the top. Okay, this is the algorithm or step that we use in push operation. First start. Next, in step 2, store the element to push in array. Check if top is equal to max size -1. It means if value of top is max size -1, it means stack is full. We cannot insert any element inside the stack. Suppose we have declared a stack that can store maximum 5 element. So index will be start from 0, 0, 1, 2, 3 and 4. So when the last element is stored at the 4 index, in that case max size is 5, 5 minus 1, 4. So value of 4 top, if the value of top is 4, then it represents that stack is full. We cannot insert new element. But if the value of top is not 4, in that case there are some space to insert the new element. So to insert the new element, at first we will increase the value of top by 1. Suppose initially stack is empty, value of top is -1. So at first we are going to insert the first element. In that case top is equal to -1 plus 1, 0. So first element will be inserted at index 0. After that, second element, again what we will do, we will increase the value of top by 1. It means top is equal to 0 plus 1, 1. So second element will store at index 1. Okay, so in this way, before inserting a new element in the stack, at first we have to increase the value of top by 1, and at the new value of top we will insert the element. Next one is the pop operation. Pop operation is basically used to remove the element from the stack, to delete the element from the stack. So what we will do, before deleting the element from the stack, at first we check whether the stack is empty or not. Why? Because if stack is empty, it means there is no value, no element in the stack to be deleted. In such, deletion is possible only when there are some value or some data element inside the stack. Okay, so first we check the condition whether the stack is empty or not. If stack is empty, then we will simply display the message that stack is empty, display is not possible. But if stack is not empty, there are some element that can be deleted from the stack. In that case, the element which will be at the top of the stack, that will be selected for the deletion, and after deleting the element, we will simply decrease the value of top by 1. Top is equal to top minus 1. These are the steps that we perform, that we implement inside the pop operation. At first we check if top is equal to -1. If this condition is true, it means it represents that stack is empty, there is no element to be deleted. Our program control will come out from the loop, and program will exit. Otherwise, if this condition is not true, then access the element top is pointing num is equal to stack of top. It means the element that will be deleted from the top of the stack. So stack of top is num. It means the number to be deleted will be from the top. Okay. after deleting the element, we have to decrease the value of top by 1. Top is equal to top minus 1. Okay, this new value will represent the next element to be deleted from the stack. Next topic is stack implementation using array. Here we will understand the C program to implement the stack concept of stack using array. In this program, what we are going to do, first we have declared a header file, then we have defined the size 10. It means our stack can contain maximum 10 element. Now after that we have declared 3 function. Push function is basically used to insert the element in the stack. Pop function is used to remove the element from the stack, and display function is used to display the element of the stack. So whenever the program control, after that we have declared 2 global variable. Initially top is equal to -1. Value of top is initialized with -1, and stack is a array, and here we have passed the size variable. It means indirectly it represents the size of stack as 10. So inside the main function we have declared 2 variable. Value variable is corresponding to the number or value to be inserted in the index, and choice value is corresponding to the choice. We are going to implement this particular program using the switch case. So when we enter the choice 1, then push is performed. When we enter the choice 2, then pop is performed. When we enter the choice 3, then display is performed. Okay, so this is the while loop until the choice is not equal to 4. It means if we enter the choice as 4, then the statement or code written inside the while loop will not execute. All the statements that are written inside the while loop will execute until the for the value of choice 1, 2 and 3. If we enter the choice 4, then program control come out from the loop. Okay, so here at first we enter the choice. It means the value of choice is accepted from the user at the runtime. This is passed as parameter inside the switch. Case 1, if the value of, if we have entered the value of choice as 1, then 1 is corresponding to the insertion. So we have to enter the value to be inserted. That value will be accepted by the user, and that value is passed as a parameter inside the push function. So this is the basically calling of push function inside the main. So when this particular statement will execute, at that time the program control transfer to the definition of the push function. It means it will transfer to the segment of the program where we have defined the push function. Later we have defined in this particular program. In the same case, when we case 2, it means when we enter the value of choice as 2, then program control will transfer to the definition of the pop function where we have defined the pop function. If we enter the value of case choice as 3, then program control will transfer to the display function, and in the code written inside the display function will execute. If we enter the choice as 4, then exit. It means program control comes out from the loop. So this is the definition of the push function. Here we define the push function. This is the body of statement of the push function. Okay, this is the function signature. So inside push we are going to insert an element. So to insert an element, at first we will check whether there is any space to insert a new element or not. So for that particular purpose, we will check a condition top is equal to size -1. It means if top is equal to size -1, then it represents that stack is full. There is no space in the stack to insert the new element. So we will simply print a message that insertion is not possible. Okay. But if the value of top is not equal to size -1, it means there are some space to insert the new element. In that case, the code written inside the else block will be executed. All the statement written inside the else block will execute. So at first we will increase the value of top by 1, and stack of, suppose initially stack is empty, so top is equal to -1. We are going to insert the first element. So top is equal to -1 plus 1, it means 0. So first element will be stored at the index 0. So stack of 0 is equal to value. It means the first value will be stored at the index 0. Insertion is successful. Now we are going to insert the second element. Again, for that particular purpose, top is equal to top plus 1. 0 plus 1, 1. Stack of 1 is equal to value. Second element will be inserted at 1. Okay, so until we can perform the insertion until the value of top reach to the size -1. Suppose we have declared here a stack of size 10. Okay, so until the value of top will equal to the 9, then till we can perform the insertion. But as soon as the value of top become the 9, then the 9 value of the top represent that stack is full and insertion is not possible. Now see the pop function. This is the code or statements written inside the pop function. Pop function, as we see that pop function is basically used to delete the element from the stack. So deletion is possible only when there are some element in the stack to be deleted. So if in that case, at first we will check whether the top is equal to -1. It means if the stack is empty, then deletion is not possible. If top is equal to not -1, in that case the statement written inside the else block will be executed. So the element that will be selected for the deletion, that will be the element which is stored at the top of the stack. So here deleted percentile d stack of top, it means the value or element which is stored at the top of stack, that will deleted. After deleting a particular element, again we have to decrease the value of top by 1. So top is equal to top -1. It means here this represent the next index of the next element to be deleted. This is the code of the display function. If top is equal to -1, it means stack is empty, nothing can be displayed. This function is basically used to display the element of the stack. But if the top is equal to not -1, it means there are some element that can be displayed. Okay, so for that particular purpose, the code or statement written inside the else block will be executed. So to display the or you can say that we can simply traversing the stack. So for that purpose, we have declared a variable I. This is the loop variable, and we will print a message stack elements are. So for loop, we have used the for loop. I is initialized with the top. We are displaying the element from top to 0 index. Okay. Top or and I is greater than equal to 0, I -1 is stack of 5. So at first the element will be which will be at the top of the stack, that will be printed. Suppose we have inserted 9 element in the stack. So at first the element or value which is stored at the 9 location, that will print. If we insert the 10 element, okay, so last element will be stored at the 9th index. So at first the 9th index element will printed, then value of I will be what, 8, then it will decrease by 1, then the element is stored at the 8th index will be printed. So in this way all the values, all the element is stored are printed from 9th position to the 0 position. This is the output. So when we execute this particular C program, which is for implementing the stack using array, so this output will be displayed. So here at first enter the value to enter the choice. So there are 4 choice. If we enter choice 1, it means push. So push program control will transfer to the push function, and we will enter the value to be inserted. Push function is basically used to insert. So at first element is 11. Okay, so insertion is successful because initially the top is initialized by -1. Again we will enter the choice 1. Again we enter the second element 12. Insertion is successful. Again we enter the choice 1. We are inserting the third element 13. Insertion is successful. Again we are enter the choice 1. It means we are inserting the fourth element, that is the 4. Okay, so now enter the choice. We are we have entered the choice S3. It means now in this case we are going to display the element of the stack. So when we will enter the value of choice S3, then our program control will transfer to the display function, and inside the display function we have written the code to display the element of the stack. So element of the stack will be displayed from top of the stack. It means 4 will be at the top of the stack. This will be the second last element. This is the third last, and this is the first element. It means this is inserted at first, this is inserted after 11, this is inserted after 12, and this is inserted after 13. Okay, now enter the choice 2. We are performing here the pop operation. So when we will enter the choice 2, our program control will transfer to the pop operation, and record or written statement written inside the pop function will execute. So since here, let us see here, at the top of the stack, element is 4. So the first element that will deleted from stack will be the 4, because element is always deleted from the top of the stack. So if we enter the choice 2, then deleted element will be 4. Again we are we have entered the choice display. Okay, now the after deleting 4, there are 3 elements inside the stack, 13, 12 and 11. So this is the stack implementation using array. Next one is the infix to postfix conversion. In this section we will discuss what is the algorithm, what are the steps that will we will use to convert a infix expression into prefix expression. At first we take a stack and stack is empty. In second step, what we will do, we will traverse the given infix expression from left to right. If third, if for each character that we will for each scan character we will check whether it is the operand or it is the operator. If it is the operand, if the input string character or scan symbol or scan character is an operand, then it will append to the postfix string, output string. Okay, but else if the character scan or scan symbol is an operator, then we will and stack is empty, then we will push it on the stack. So if the scan character is an operand, then it will add it to the output string, or you can say that the postfix expression string. But if it is the operator, then it will add it to the stack, it will push to the stack. Okay, else if the stack character or symbol in the input string is a closing parenthesis, the operators there is the left parenthesis, and after that there are some operators, and after that there is the closing parenthesis. In that case, what will happen, all the operators that are enclosed inside the left parenthesis and right parenthesis, that will be popped from the stack and added to the output string, postfix string. Okay, next, if the operator which is present at the top of stacks has lesser precedence than the currently stacked operator, then expression put the operator on the stack. Suppose on the stack there is already an operator. Okay, so what happen in this case? In this case, we will check the precedence of the operator which is currently at the top of the stack and the current operator. If the precedence of the operator which is stored at the top of the stack is greater than or is less than, then we will simply push the current operator onto the stack and will do nothing. But here, if the operator which is presented at the top of stack has greater or equal precedence, then current scanned operator in the expression, then pop the operator from the stack and append it to the output string. It means whenever we are scanning the given infix expression, if the an operator is occurred and on the stack there are also some operator, in that case we will check the precedence of the operator which is present at the top of the stack to the current scanned operator. If the operator which is present at the top of the stack has the equal or greater any of them precedence, in that case that operator which is stored at the top of the stack will be removed from here and it is added to the postfix expression or output string, and current operator is pushed on the stack. Okay, this will process if the end of the input string is encountered, then all the operators pop out from the stack and will append to the output string. Let us see an example. This is an infix expression: a multiply b divide left parenthesis c minus d right parenthesis plus e multiply left parenthesis f minus z. So we have to obtain the postfix form of this. Okay, so as per this algorithm, this is the algorithm to convert the infix expression into postfix expression. First, we will traverse this given expression from left to right. So first symbol or first character is A. So since A is here, it is written in capital, no problem. Since first character is A and A is an operand, so it will add it to the postfix notation or postfix string or output string. Now again, the next character is the multiply. Initially stack is empty, multiply is an operator, so operator it will push to the on the stack. Okay, after that b is an scan symbol or input string is b, then b is an operand, so it will be added to the postfix expression. Okay, b. After that, next character is the divide. Divide is what? An operator. Divide is an operator, so it will push on the stack. Now let us see here. Since on the stack on the top of the stack multiply is there, and after multiply we are going to push the divide operator. So here we compare the precedence of multiply and divide. Since the precedence of multiply is equal to the precedence of divide, so multiply operator will pop from here and it will add it to the append to the postfix string. Okay, so multiply will pop from here, remove here and append it to the postfix string, and we will push the divide operator here. Okay, after that again there is the left parenthesis is an operator, so put on stack. After that there is operand c is operand, so it will go to the postfix string. After that minus is an operator, so after parenthesis it will push on the stack. Again after that d is an operand, so it will push to the output string. Right parenthesis, so what happen here, the right parenthesis occur, so the inside the left parenthesis and right parenthesis, this minus operator is enclosed, so this minus operator left parenthesis will cancel to the right parenthesis and minus operator will pop from here and it will append it to the postfix expression. Okay, after that plus operator and on the stack there is now divide operator. So we will compare the precedence of divide with precedence of plus. Since the precedence of divide operator is greater than the plus operator, so in this case the divide operator will remove from the stack and it will add it to the postfix expression. Okay, so after that e is an operand, so it will add it to the postfix expression. After that multiply is what? Multiply is an operator. Again now see this, since the precedence on the top of stack there is plus and current operator is multiply, since the precedence of plus is less than the precedence of multiply, so in this case nothing will be pop out, we will simply push the multiply operator after the plus. Again after that after multiply there is the left parenthesis, so push on stack. After that f is an operator, f is an operand, so it will go to the postfix expression. After that minus operator, so it will push on the stack. After that g is an operand, so it will add it to the postfix expression. And after that there is the right parenthesis, so right parenthesis is here. So what happen in case of right parenthesis, the minus operator is enclosed, so minus will remove from here and add it to the postfix string. Okay, now the complete expression is traversed or scanned. So here what we will do, all the operators which are on the top of the which are in the stack, that will remove and add it to the postfix string. So here the parenthesis, right parenthesis, left parenthesis cancel, minus is removed from here and push on the stack. Now the next operator is multiply, so multiply will pop and add it to the postfix string. After that plus will is removed and added to the postfix string. So here the stack is empty. So this is the postfix expression of this infix expression a b asterisk c d minus divide e f g minus multiply and plus. This will be the postfix expression of this infix expression. Okay, thank you.